Hello everyone, welcome back to our Artificial Intelligence and Machine Learning lecture series. Today's topic is A-star algorithm, one of the most important informed search algorithm used in AI. By the end of this session, you will understand what is A-star algorithm is, why it is called an informed search, how the evaluation function works, step-by-step algorithm, practical example, and advantages, disadvantages, real-time, real-world applications. First, let us understand what is A-star algorithm actually means. Suppose you want to travel from your home to your college, there may be several roads. Some roads are short, some roads are having traffic, some roads are longer. Which roads would be you will choose? A normal search algorithm may simply keep exploring roads until it finds the destination. But A-star is much smarter. It predicts which path is likely to reach the destination faster. That is why A-star is called informed search algorithm. It uses additional information called as heuristic function. The heuristic function estimates how close we are to the destination. Therefore, A-star expands fewer nodes than uninformed algorithms and usually finds the optimal path. This makes A-star one of the most popular search algorithm in AI. The heart of the A-star algorithm is its evaluation function. The formula is f of n equal to g of n plus h of n. Now let us understand each term. G of n. G of n is the actual cost from the starting node to the current node. Suppose we are already traveled 20 km, then G of n is 20. And h of n is the estimated distance from the current node to goal node. Suppose GPS predicts another 15 km, then h of n equal to 15. Now find f of n equal to 20 plus 13 equal to 35. The algorithm always choose the node having a smallest f of n. The simple equation makes A-star both intelligent and efficient. Think of Google Map. It calculates distance already traveled, estimated distance remaining, then it's recommended the best route. This is exactly the working principle of A-star search algorithm. In this A-star algorithm, we are using data structure two important lists. One is open list. The open list contains nodes that have not yet been explored. Think of this as a waiting queue. That means waiting queue. Whenever your new nodes are discovered, they are placed here. Okay. Next, the open list is usually implemented using priority queue. The node with the smallest f of n gets the highest priority. And next one, closed list. Closed list, it contains nodes that already have been explored. Once a node is placed into the closed list, the algorithm usually does not visit it again unless a better path is found. Using these two lists reduces unnecessary searches. As result, as execution becomes faster and memory usage becomes more efficient, and we are following steps to find the goal. First, step 1. Step 1. Place the starting node in the open list. For example, starting node is A. We will go to A into open list. Okay. Next, step 2. Check whether the open list is empty. If it is empty, there is no possible paths. The algorithm stops the search. Next, step 3. Choose the node having the minimum value of f of n, that is g of n plus h of n. If node is the goal, the search is stopped. Otherwise, the search will be continued. And next, step 4. Expand the selected node and generate all successor nodes. Move the expanded node into the closed list. Okay. And step 5. For every successor, check whether it is already exists in the open list or closed list. If not, calculate g of n, h of n, and finally f of n. Store it inside the open list. If the node already exists but a better path is found, update the parent pointer. And final step is repeat until the goal node is reached. This process continues until the destination is found. These 6 steps form the complete A-star algorithm. Advantages and disadvantages of A-star algorithm. First one, it is better algorithm than other search algorithms. And next, it is optimal and complete. The process of search is optimal, so also have a completeness. And it exposes fewer nodes and it finds better solution. And it can also solve very complex problems. These are the advantages of A-star algorithm. And it widely used in practical applications. Okay. And some drawbacks are also have. It does not always produce the shortest path. Maybe it produces longest path also it will produce. And it is not practical for various large scale problems. Okay, these are the 2 drawbacks. Next, we will see about applications of A-star algorithm. First one, GPS navigation. The most common application of A-star is the GPS navigation system. When we use Google Maps or another navigation apps to travel from one location to another location, there are often multiple possible routes. The navigation system evaluates each route based on a g of n and h of n. Okay, and it selects the route with the lowest total estimated costs. For example, you are traveling from Coimbatore to Chennai. The GPS compares different routes and suggests the fastest or shortest route. If traffic conditions changes, it recalculates the route and recommends the better path. Okay. Next, we are using A-star algorithm in robotics. It is widely used in robotics for path planning. Consider a warehouse robot that needs to move from one storage rack to another storage rack. The robot must avoid obstacles such as shelves, workers, and any other robots. Okay, it calculates the safest and shortest path, helping the robot reach its destination efficiently. Similarly, it uses in autonomous mobile robots used in hospitals, factories, and warehouses. It really A-star is used in navigate through complex environments. Okay, next, a gaming in artificial intelligence, game development. Another important application is video gaming. In many games, computer-controlled characters must move intelligently from one location to another location. For example, if an enemy character needs to chase a player, it should avoid walls, rocks, and other obstacles. It helps that means A-star helps the game characters determine the shortest route to the player's location while avoiding blocking paths. This creates more realistic and intelligent gameplay. And another in our area, automotive autonomous vehicle. In self-drive cars also use path planning algorithms based on concepts similar to A-star. The vehicle continuously calculates the safest and shortest route while considering road conditions, traffic signals, and other vehicles. By constantly updating the best path, autonomous vehicle can travel safely and efficiently. And finally, route optimization. Many logistics and delivery companies use A-star for route optimization. Companies such as courier services, food delivery platforms, and emergency response systems need to find quickest route to reach customers. Okay, for example, a delivery vehicle carrying multiple parcels must visit several locations in the shortest possible time. It helps determine the efficient route, reduce travel time, and fuel consumption. Okay, next we are going to see an example for a A-star algorithm. In this algorithm, in this problem, we have a start node is S and the goal node is G. And in this function, we have h of n and g of n. We have to find out g of n and h of n. Okay, already h of n and g of n is shown in figure. This image demonstrates the working of the A-star algorithm step by step. The objective of this shortest path finding from node S to goal G using the evaluation functions f of n equal to g of n plus h of n. Already we have discussed g of n, h of n, f of n. Okay, we are using following steps to find for shortest path. Step 1. First, we have to find out understand the graph. In this area, we have mentioned S2A cost is 1 and S2G cost of 10, A to B cost of 2 and A to C cost of 1, B to D 5, C to D 3, C to G 4, D to G 2. Okay. And step 2 starts at node S. Initially, open list is S. Okay. Expand node S. There are two possible paths. One is A, another one is G. Okay, please refer this image. First, we have calculate the f of n for path 1 and calculate f of n for path 2. Okay. Path 1, S to A, actual cost is G of A equal to 1 and heuristic value H of A is equal to 3. Therefore, f of A equal to 1 plus 3 equal to 4. Okay. Next, we have to find out f of n for path 2. That means S to G. Actual cost of G of G equal to 10. H of G equal to 0. Therefore, f of G equal to 10 plus 0 equal to 10. Okay, we have two paths. Path 1 have a cost of 4. Path 2 having the cost of 10. Okay, now the A-star algorithm finds the shortest path, that is S to A, f of n equal to 4. That is the lowest cost of search. Okay. Next, and step 3, expand node A. From node A, there are two successor nodes. Option 1, A to B, option 2, A to C. Okay, now also find f of B and f of C values and compare two values. Okay. First, option 1, A to B equal to f of B value 3 plus 4, 7. Option 2, A to C equal to 2 plus 2. That means G of C equal to 1 plus 1, 2. H of C 2. Therefore, f of C equal to 2 plus 2, 4. Okay, we have two options and two path costs. One is 7, other one is 4. Okay, the algorithm compares two values and it will search starts from lowest path value, that is selected 4. And next, step 4, expand node C. Node C also have two possible paths. One is C to D and another option is C to G. We have to find f of D for option 1 and f of G for option 2. First, option 1, C to D. Actual cost of G of D equal to 2 plus 3 equal to 5 and H of D equal to 6. Therefore, total f of D equal to 5 plus 6 is equal to 11. Okay, the path value of option 1 is 11. Next, option 2, C to G. The actual cost of G of G equal to 2 plus 4 equal to 6 and heuristic value H of G equal to 0 for G. Therefore, total f of G equal to 6 plus 0 equal to 6. Okay. Now we have to compare the two values and find smallest value and also reaches the goal node G. Okay, first compare option 1, option 2. A-star algorithm finds the shortest path. That means C to G, option 2. Okay, now finally we will get path S to G equal to SACG. That means path cost is 6. And final path is shortest path selected by A star is SACG. Okay, and total cost of the search is S to A equal to 1, A to C equal to 1, C to G equal to 4. Total cost is 1 plus 4 equal to 6. Okay, that is also optimal path. There is no shortest route for reaching goal G. So this is the optimal path. That means SACG. The total path cost of the search is 6. I hope this session helped you understand A-star search algorithm clearly. If you found this lecture useful, please like the video share it with your friends, and subscribe to the channel for more artificial intelligence and machine learning lectures. Thank you for watching. Have a great day.